Hey guys, Wadox Studios here, and today we're going to be compiling shaders. I'm joking. Um, as you can see, I'm in 544, and I have a project named Older Hardware Targets. Now, I saved you guys some time, and this is a brand new third-person template project, but my previous video went over VR development and mobile development in Unreal Engine. And I talked about a branch that I'm keeping up to date with, like the most recent Android settings and being able to push to the Quest and Quest 2 and Quest 3. And I talked about how for me it's just easier to get from like point A to point B with UE4 and trying to stay under that 11 millisecond target. Like, so optimization is a big deal. I also mentioned how UE4 still supports like GL and ES31 and older like Mali chipsets, etc., etc. And there was a huge interest in like, well, what if I wanted to support 8th gen consoles? Or what if I wanted to target older hardware in UE5? Like, it's not going back as far as like, say, mobile devices, or ES31. They consoles are equivalent to desktop applications or desktop games, right? And the only difference is that like we're really talking about. I mean, at the end of the day, the segment in the video where I was stating the differences between DirectX 11 and 12. If you're talking about like desktop, 8th gen and 9th gen. So like your older GTX cards, your early 2000 series cards, and consoles, switches, PS4s, etc., etc. So the great news is UE5 is good at this. It scales really, really well. Now, you wouldn't know it based on the default settings because you're going to load in an SM6 and DX12 right out the gate. And my machine's a pretty bad example of this, but because I'm on a 2080 Ti on this machine, it's not too far out there. It's not my 40 series machine, and it's not my 1050 Ti. And just so you guys know, I have a different scale of machines because targeting the actual hardware you're developing on is important. Like, the machine is probably the best way for you to understand how something's going to run. So I have a machine with a 1070, I have a machine with a 1050 Ti, and I have a machine with a 2080 Ti, and I have a machine with a 30 series card and a 40 series card. So like, I'm a big nerd. I know it. But anyway, yeah, let's get started. We'll look at some things. Immediately right out of the gate in a default project, you're gonna see that Lumen is already on, and it's using the global tracing path, so that's the faster path. We haven't tweaked any of like its update rates or nothing like that, but as of right now, it's on. The other thing in UE5.4, also disclaimer, DX11 Lumen doesn't work in 5.5. Engineers said that they were going to be trying to hotfix it in, but as of this video, I'm doing all of this on UE5.4 because of that reason. So yeah, back to it. If you go to hardware, ray tracing, let's see, there's going to be a Boolean value. I don't have it turned on. It doesn't come on by default. I think it's on in UE5.5. So again, all of this is UE4 default settings. We're not going to change anything. I just wanted to point those at you. And if we go look at the RHI, you'll see it's at DX12 by default. And if we go look at SM6, it is enabled by default. So that's the baseline. That's where we're starting when we load up UE5.4, right? And I'm on a good mid-ranged machine right now. Like a 2080 Ti is a pretty beefy machine. If you go look at Steam stats to see like what most people's hardware is. And if we do a stat FPS right now, you're gonna see I'm at 90 frames per second. And that's in the default template with no changes. And it's like, okay, well, what the hell is costing me so much? Okay, so we're gonna do a stat GPU and we're gonna look. Well, it looks like TSR right now is costing me a whole 2 milliseconds. And that's crazy because I'm on a 1080p display right now. I'm not upscaling to 4K. I don't even, technically, TSR is wasting resources for me right now. I don't even need it. So we'll turn stat GPU off, and we're not gonna even go from DX12 back to DX11 just yet. We're just going to say, let's go look at this AA method. And we'll just think about this from a previous gen anti-aliasing. So we can go to TAA initially without changing any settings and hit play. And you'll see right out of the gate, I have pretty good AA. You're going to get the same temporal smearing that you would get from TAA. So that is a little different than TSR. TSR does a better job of keeping smearing low, but it still smears. It's still a temporal solution. TAAU can still upscale. It still can do everything that TSR can do. But if we go look at stat GPU, there is no cost for upscaling. There is no cost for anti-aliasing. I mean, it's there. It's 0.15 milliseconds or 0.16 milliseconds. But right out of the gate, you just went over 120 frames per second. And I could unlock my frames, but there's no point at this point. Like, the point is made here. So now you're like, okay, I didn't do anything. And we'll look at the stats unit real quick because stat game is going to be dirt cheap right now. Like, we're not even talking about trying to optimize for, like, yeah, we're at 4 milliseconds on the game thread for, like, chaos and hit traces and game logic right now. We're completely GPU bound at the moment. So, and I would expect that out of a template project. So we've to hit a mid-range decent card at 2080 Ti is no slouch. We've essentially done what we needed to do at the GPU state to give yourself overhead to work with to start, tossing things in. I am still Lumen capable at this point, so if I wanted to use Lumen, I could enable it. I've already paid for the overhead right now. Like, I am in a Lumen capable rendering setup. However, the moment you enable Lumen, you are going to start paying for software rasterization, and anytime you start using world position offset things that, foliage that blows in the wind, or any type of like claw simulation effects, etc., displacement, tessellation, those kind of things, you're going to pay more. Nanite is not built for that kind of stuff. The other thing you're going to pay more for is any type of overdraw that you're having on quads. So quad overdraw becomes really important in a nanite enabled scene. So just keep those things in mind if you go that direction and you start scaling up from here. But I'm going to take things even further. Like, I'm going to screenshot this. I'm going to hit print screen. So, like, this is where we got back to after simply changing anti-aliasing. So, actually, if you hit Shift Escape, you can just stop. I'm going to hit F11 here. So now, let's take this a bit further, shall we? You'll notice the RHI command here is profiling the cost of SM6. So what we're going to do now is we're going to gain, we're going to start counting like low-hanging fruit at this moment, but The next thing you could technically do is you could say, instead of SM6, I'm going to target SM5, which is a cheaper shader model. So you don't want to, and I would say, why would you even do this? But say you don't want to move down to DX11, but you do want the cheaper shader cost. You don't want SM6. You want to go back to SM5, which is cheaper. This gets you in line with what you would be doing in UE4 on DX12, because that's where we are with UE4. So it's basically DX12 SM5, right? And again, it's yelling at me, hey, you need virtual shadow maps. So that's where this comes into play. This is a really easy thing. Also, this is where this starts getting a lot cheaper. Your shadow costs are going to go down. We're just going to disable this. And then we're going to let the shaders compile. And as you can see here, like, it's not a huge loss. This is not, like, comparatively speaking, this scene does not look drastically different. Not at the point where, you know, and I guess, like, video files and people who are, like, really anal about the visual presentation of, like, you know, upper high-end renderings would notice this and nitpick this to death. But if you're wanting to just look really good on HN hardware, you're not going to notice this too much. And we'll just hit play, let these compile out, and here we are. DX12 SM5 cascade shadow maps, not virtual shadow maps. And you'll see the cascade effect here. Like, if you look right in front of where my character's standing, you'll see how the shadow kind of like cascades into multiple versions. You have a really crisp up close shadow, a little bit of a medium blurry one, and then farther away you get really blurry. You get the third cascade way down there right before, it's going to be right here, but right before the little box thing down there. However, let's do a stat GPU. As you can see, we're down to 7 milliseconds. We just got the hugest savings. And then if we do a stat FPS, you'll see we're still crammed out at I'm gonna actually what is it, max FPS. We'll do, I think I just have to do some big number in this one. So yeah, we're well over 120 frames per second. Lumen looks to be the biggest cost right now. Everything else is pretty low. Volumetric clouds are costing a bit. I mean, they are cheaper now because they're SM5 versus SM6. But we're DX12. At this point, you got to ask yourself, why are we even doing this? Again, if we go to stat unit here, in UE5, you would be able to see like how much memory utilization you would be using. But yeah, in 5.4, your stat commands are a little bit different. Your stat unit draw shows you a little bit different. Let's see, stat unit graph real quick. And then like here is the graph. We're well under a budget. I mean, we could technically rock with this if we wanted to, but I would make the argument, if you're SM5 and your cascade shadow maps, why eat the extra memory in DX12? Just let your DX11 8th gen cards rock with DX11. So that's what we're going to do now. We will hit escape, shift escape, sorry. We will go into project settings. We will go to RHI, and we will go to DX11, and we'll restart. And if you didn't notice, global illumination never stopped working for me. It's not going to stop working. And we can we'll do something real quick. we'll create a new material. Yeah, 3 vector. Yeah. And this can be green. Default lit is fine. I'm just gonna give this a little boost real quick. That'll work. I don't need this open. I don't technically need this open. And we will copy and paste this over here. Now, again, I'm gonna have a little teensy weensy difference in lumen cost, but it's gonna get heavier, not lighter. So, like, promise you, I didn't impact it that much. So yeah, lumen is still working. If we look at stat RHI, we have really, really cheap memory costs unit. We'll do stat GPU. I don't need stat RHI up anymore. But yeah, on the right hand side, you'll see that we are now down to 8.33 milliseconds. Let's get to stat FPS. And we'll unlock our frames. And we are over, we're hitting 140. We're well over 133. We're at 6.2, 6.1 total frame time now. So, and this is UE5 with Lumen, with software ray tracing. And the only difference I did was switch back to DX11. But again, this is a 20 series card. So, you know, I like I said in the video where I was covering mobile optimization, like, just because cards say that they're DX12 ready doesn't mean that they do DX12 better. I just stepped through all of this with you, and I showed you that, like, literally I gained 1.5 to 2 milliseconds just from switching from DX12 to DX11. I dropped almost 700 megs, I think, of total memory usage. It is what it is. But anyway, this is UE5, and we are equivalent to where, with Lumen now, GI, we are equivalent to the rendering capability of where 427 was, right? So we just kind of stepped back in time a little bit and still kept a couple of the rendering capabilities that UE5 brings with it, which is software global illumination, software ray tracing, global illumination. Again, I still don't have hardware ray tracing on, and we're kind of straddling this area where I've pushed projects to Steam Deck with global illumination by moving back this way, tossing out SM6, only using Lumen GI, going back to DX11. So yeah. What if you're like, okay, well, I want to save even more. I still want to be in desktop, the desktop realm, but I want to hit 1050s. I want to hit GTX 970s and 980s. Those are still really good cards, and they're still really, really popular on Steam. People are still rocking the higher end old school GTX cards because the bang for your buck on the core speed is there. So yeah, let's talk about that then. Okay, what do we want to do if we want to get more savings out of UE5 from this point? Well, we could do what we do in VR. we can swap to forward rendering. So if we look for this checkbox right here called forward shading. Now you will lose lumen at this point. Lumen is a deferred method. Your base pass is going to handle everything, all of your lighting. You're going to move to a cell-based lighting approach, but you're going to get extremely fast. As you start throwing more and more and more lights into the scene, you're going to pay for this more and more and more. So this is where the argument between what optimization is like kind of starts to take place. In the previous video I said UE5 you pay for things up front. In order to support nanite, you pay for them. You turn on SM6, you turn on DX12, you have a software rasterization pass that is thrown into the scene. You need virtual shadow maps for nanite to work properly. You're paying up front for all of these things. In this model, we're using HLODs. We haven't enabled nanite. We're using the traditional optimization passes. So you're getting what you pay for. Like whatever you tick, whatever you turn on, whatever you do is what you pay for. Going back to forward rendering means exactly that. The base, there is no deferred pass. The base pass pays for everything, all of your lighting, whatever you see is what you get. The good news is that they've developed a way to cull those lights if they're not in the scene. They set them up in a grid, and it's essentially forward plus. So like you're gonna get even better performance than you if you were to go back to say like UE3's forward rendering. So let's enable this box, and we'll do the necessary restart. It's cool. We'll save the cube. Now, when this boots up, you're gonna notice that lumen no longer works. Actually, let me pause the video right here for you guys, and I'll come back. I don't want y'all waiting this long for shaders. Okay, we're back. So I'm gonna take this little bit of time while these last shaders compile to talk about something when it comes to like forward rendering and deferred rendering. In deferred rendering, TAA is your best anti-aliasing method that you had available to previous gen, like older target hardware. TSR is available to that older target hardware, but as you saw, the cost is pretty substantial to run it. TAA has been what's been used. TAAU is what's been used in UE4 in deferred rendering, and even though it has ghosting and motion smear and all these other issues that are associated with it, it is probably the most performant method of you know, outside of your TXAA, you know, like the ones that don't do so great at like specular aliasing and other methods. TAA is kind of like the good balance between visual fidelity and sharpness. And forward rendering, that's not true. Forward rendering has by far what I would argue would be the best anti-aliasing method, which is MSAA. And we're now in like VR territory, right? So like if you're developing a VR experience, you're probably familiar. And as you can see, we can go ahead and get rid of this little guy because lumen is no longer working. So we'll just delete that out of the scene. Boop. Outside of lumen not working, there's not a huge difference between deferred and forward right now. I'm gonna start this up with stat unit so you guys can see the performance real quick. So yeah, we'll full screen again, and we'll do stat unit, and we'll do stat FPS, and we'll do stat GPU, so we can see what's going on here. And as you can see, like TAA is still there. It's 0.21 milliseconds. We're still over 130 frames per second. We'll go, if I can type correctly, we'll put this up to something huge, and you can see just from switching from deferred to forward rendering, changing nothing, we're over 200 frames, and this is in UE5. And I would argue that the visual fidelity loss here is not huge, but we're still in TAA, so we're still going to get this ghosting that you see when you move around. However, now we're starting to enter the realm of rendering where like the nostalgia and like the old school gamer in me loves. So as you can see, my total MS cost at the top there is 2.5 milliseconds on the GPU, and we're at a total of 4 on the stat unit graph, which means that we're approaching a place where our frame time, our game and our frame time, our GPU and our CPU are in harmony. Our total bottleneck now is a balance between the two. It is no longer bottlenecked by the GPU. So good news there, right? So we are going to hide this. We don't need this anymore. Without those graphs showing, we're not paying for the overhead. You can see we're hitting 300 frames per second. Like, and now we're gonna hit shift escape, and we're going to go change anti-aliasing method, and it's going to cost us just a little bit for MSAA, not much, and we'll come back and we will Alt P and we will F11 to full screen, and you'll see that we are super sharp. MSAA has no frame smearing. There is still motion blur going on, but I would argue like disable motion blur in forward rendering with if you want the crispest, sharpest, most performant running version of this. And we'll go look at that stat unit again. And we will turn on stat GPU again. So we're at 3.2 milliseconds. The other thing that I want to make you guys aware of, and you know, we have the MSAA cost that's there, but it's like off in the distance there, the edges of these boxes, etc. Like you are getting close to pixel perfection on the aliasing and the sharpness of the scene. Yeah, depth of field, motion blur, those kind of things, I would make the argument. If you're in forward and you want the crispest, most clean picture you can get, go disable those effects. So yeah, we are at Switch territory and VR territory now. Like instant stereo enabled, you would be at a place where you would start. This is what you would be, where you would be at if you were developing like a PC VR experience, but it's also where you would be at if you were aiming for like the Nintendo Switch. Yeah, plenty of overhead to work with. Just got to be kind of mindful of how many dynamic casting lights you throw into your scene, because that's going to drive your cost up as you add more, especially if they overlap. But yeah, UE5 can run like a scalded dog. You just got to know how to work the engine back to rendering for these older hardware targets, and you got to know how to work within the UE4, HLOD, and LOD grouping system to continue to follow out what these older cards enjoy as far as optimization goes. On the subject matter of AA, and we talk about MSAA and TSR, or TAA, right? TSR is where the industry went with deferred rendering, because once they moved to deferred rendering, they had to have kind of a multi-sampled AA method that's post-process, and the argument was TAA was cheap. But the funny thing is that it's more expensive than MSAA was when we left it, where we regarded MSAA as the most expensive method compared to TAA. Like if I was to go swap to TAA, I'm going to pay less in forward than I would for MSAA. And that was kind of why it introduced itself. It was the cheaper and almost good enough. Like it was the good harmony balance to like get us over the edge with rendering in this base path based rendering method forward. And then in deferred, it was just a magic bullet. It was like, oh, well, we can defer lighting, we can make the rendering pass even cheaper, the base pass even cheaper, make our shader costs cheaper, and we can use TAA and have this balance, this harmony. But I would make the argument that we've moved so far in that realm now, where TSR and these upscalers are actually doing more work than the pixel perfect 1080p images that you're getting out of Forward with MSAA to give you that super sampled sharpness around the edges, that it's just like the purist in me enjoys this place of going back to Forward base rendering and MSAA so much, because you get the equivalent of having to do TSR 4K upsampling to get the same quality you would get out of a 1080p image with MSAA tossed on top of it, and you're not paying as much. So now I'm gonna get into like the nerdy talk of like Forward and some things to keep your head around. Like, so with foliage, with translucency, with overdraw, quad overdraw, etc. All of these things are going to be things you have to pay more attention to in Forward rendering. And you have options. You have an additional pass. So I'm going to stop playing real quick with Shift Escape. We don't need stat unit up here anymore. We don't need stat GPU up here anymore. So if you go into your project settings, you're going to see this thing called early Z if you type it in. And it's going to say decide automatically. Now, I would make the argument that this doesn't work very well. If you're doing a scene, or if your game consists of a lot of foliage in Forward rendering, you want to mask both your opaque and mask mesh, or opaque and mask meshes in your early Z. And what that's going to do is it's going to cull the back. It's not going to draw what's behind your masked scene. So you're going to pay less for overdraw. It's going to just cull it out. It's going to check it in an early Z pass and get rid of it. So anything that's behind another thing, you're not going to pay for it. You're going to reduce your quad overdraw cost and your translucency overdraw costs for like high foliage scenes. And this is really important in VR. But for like the Switch and other older targets, I would say like do a profile between the settings on this and find out what plays well with the type of scene that you're developing. The other thing you're going to have is a separate translucency, and that might be just on the material itself. Let's see. I think it's here. It's already on, so no need to worry about that. You're gonna save a little bit having a separate translucency layer. So it's almost like an additional buffer. It is an additional buffer that's gonna handle translucency pass. And the other thing with Forward rendering and translucency, you don't have to struggle with things the same way. And I guess the best way I can show you this is to make another freaking we'll just duplicate this. And wait, did I not? Oh, I duplicated the wrong one. That's a material instance. So I'll duplicate the glow, and we'll just name this like glass or something. So in deferred rendering, you have this, you have deferred doing what deferred does. You basically have this fighting that goes on with translucent materials. Because of the way deferred rendering works, you're doing everything that has to do with like glass rendering, opacity, translucency. You're doing these translucent materials in the Forward pass anyway. But because it's a deferred renderer, you end up with basically this translucent layer depth fighting issue where deferred just does not handle that type of thing very well. It doesn't handle opaque or non-opaque translucent materials that are stacked and trying to cull with each other and draw within that rendering framework, versus Forward, you're running what is running when you're doing glass anyway. And a good way to notice this is like when you go to this translucent, you go to shader model, you have these thin translucent subsurface profiles, default lit, etc., etc. Each of them are going to tell you like what the lighting mode is, and it's going to explain to you like what it's doing for that lighting mode. But if you come down to surface forward shading, and you'll see that this is like glass and water, it says that because regardless of whether you're in deferred rendering or forward rendering, you're using forward shading to do this. So we're already here. We don't have to worry about drawing an extra shading rendering pipeline on top of a deferred rendering pipeline to handle translucency. Things in the forward renderer just kind of work. I'm going to change this color. We're going to go to something like gray, like a light gray. We'll do like half. And we'll turn the roughness value to nothing. And we have glass. Yeah, so if I hit save here, and we go line some boxes up, first off, what you're going to see is your instruction count's a little heavier than it would be. It would be a little cheaper in the Deferred. And that's going to be across all your materials, no matter what. In forward rendering, your base path is more expensive because base path is handling all of your lighting data as well. So we'll toss this on here, and we'll toss this on here, and as you can see, you don't end up with this weird, I mean, you can even see the edge of the glass here. You don't end up with this weird situation like you would in the deferred rendering, where you're having a hard time rendering surfaces that behave like glass. It just knows the layer it needs to be on. It knows the type of material it needs to have. Let's see. And you also have blurry glass and water type shaders that are a little cheaper than the surface forward shading. You'll start seeing differences in cost as you come down, but you'll also start seeing differences in quality as far as like shadows rendering on the surface, etc., etc. But you'll just see that forward tends to handle these guys a lot better. And then if you go into like your, of course, visualize, optimization view mode, and we go to shader complexity, you're going to see where your cost is going to come in. As things overlap here, you're going to get more and more and more expensive. So, you know, just be aware of that. The other thing too is like, I don't know if these things are really this expensive or not. That seems like a lot. Maybe the forward rendering view mode is broken, but we'll go back to lit. Now I'm all curious. Why is this guy red? Let's go look at this shader. Uh-oh. It has a specular cost on it. Still shouldn't be that expensive. The other thing too in forward is if you come here and you another performance saving thing is going fully rough. If you are fully rough, if you're going to just be hard coding a one value to your roughness, you might as well mark the shaders fully rough and cut your costs back. It's a little trick, little tip. Most people don't know about it. Outside of that, it looks like we are just a freaking base color and a metallic value that is hard coded to nothing. We can close out of this and go back. Go back to shader viewport. And now we're green. So that's just a little trick there for you. I don't know why these other guys are not green, but it's likely going to be specular and roughness that is going to give you that cost. And it's really easy to tone all that back. Just be aware of that view mode and how to change it. But yeah, even with the shader cost being at this, I'm still hitting well over 200 and something frames per second. That's pretty much it. I mean, at this point, you can start following older UE4 guides, because it's gonna be pretty much the same between UE4 and UE5 once you start stepping back this far. You know, some of your shaders in forward rendering that rely on TAA, now that you're in MSAA, are going to look a little different. You're going to have to rework the opacity value of some of your, you know, translucent, or I would say mass materials, your foliage rendering stuff. You're going to have to rework the bias for your opacity mask. Just because deferred and forward handle that a little differently, but you're still going to be able to get really good visual results if you know how to, like, if you do your homework and you start learning how to work within forward rendering and MSAA. You're not going to have things that look good like TAA, temporal smoothing, like your little fade effects and stuff like that. They're just not going to look that good in forward, but there are other ways to do similar effects in forward. So we're down to 2 milliseconds. And again, if I was to put this on a 1050 Ti, it would run at over 100 frames. Like, it does not cost that much to run this. So hopefully this has been useful to you guys. And I want to say thank you for the people that took the interest in the mobile and the VR optimization video that I did, where I was talking about UE4 for, you know, the meta branch for Oculus and mobile development. If you guys haven't checked that out or you're interested, I ported the Oculus SDK over to 427 Plus just to kind of future-proof it from further deprecation if Meta decides to deprecate UE4 or their API and SDK further than what they have, trying to aim at Android 32. The only reason, again, UE5 has a ES32 and a GL limitation on OpenGL on what it can support. So, like, that's the only reason there. When it comes to desktop development or trying to aim at older targets like your 8th gen consoles, there's no reason that you at this state can't use Unreal Engine 5.4 if you want Lumen software ray tracing. But you want to be able to hit older cards like your high-end GTX cards or like your 20 series cards, and you want DX12 SM6 like I showed you out of the gate, you're going to have to stay on UE5.4 for now until the hotfix comes for 5.5, and they add that support back for SM5 Lumen software ray tracing. Otherwise, yeah, all Lumen is going to be gated behind DX12 just like nanite, and you're going to have a huge overhead cost that you're going to have to pay just to be able to enable a GI. And you know, I love UE5, but I do have feelings about how they're artificially gating things behind what I would say would be a poor optimization path or choice for optimization, where you could still be supporting these older cards and offering rendering capabilities that no other engine can offer. 427 can't do software ray traced Lumen on DX11 and SM5. It's not there. It's not a feature. So, you know, hopefully UE5.4 isn't the last version that can do that. But anyway, thank you to all of my Patreon members. Thank you to the Oculus Start Discord, and to you guys in Modox Studios Discord that reached out and was like, hey, you know, would you mind doing this for 8th gen consoles and like desktop hardware? Like, show us kind of like how you would step back in UE5 without going to UE4 if it's good enough there. So hopefully, like, this shows you guys that I do have a lot of love for this engine as well, and like there's a lot of options here on it. Until next time, guys, happy developing, and toodles.